Hello, everyone. Thanks for watching. We continue with Smart Society and AI, and this time it is Chapter 5. So, Chapter 5, and let's see the topics we cover this time. Now, understanding how data analysis work, then also uh, defining data analysis, so understanding why analysis is important, reconsidering the value of data, and then defining machine learning, so ML, understanding how machine learning works, what are the benefits of machine learning, and the limits of machine learning, and as well considering how to learn from data, so the three types of learning methods: supervised, unsupervised, and the reinforcement learning. Let's jump in. Okay, so collecting data isn't a modern phenomenon. Also, the way we collect it and the scale is relatively new. People have recorded data in various forms for centuries, regardless of whether the information was in text or numeric format. People have always appreciated how data describes the surrounding world, the environment, and among other things, they used it to move civilization forward. Data has an inherent value. By using its content, humanity can learn, transmit critical information, avoiding the need to reinvent the wheel, and effectively act in the world. So this chapter discusses how data also contains more than just surface level information. If data is in a suitable numerical form, you can apply special techniques devised by mathematicians and statisticians, known as data analysis techniques, to extract even more insights from it. We also show how, starting from simple data analysis, you can extract meaningful information and subject data to more advanced analytics using machine learning algorithms capable of predicting the future, classifying information, and effectively helping in making optimal decisions. So data analysis and machine learning enable people to push data usage beyond its previous limits, to develop smarter AI systems. This chapter will introduce you to data analysis, which serves not a lesser solution compared to generative or conversational AI, but instead forms its very foundation. You find out how to use data as a learning tool and a starting point for solving complex artificial intelligence problems, such as suggesting the right product to a customer, understanding spoken language, translating English into German or Korean, automating car driving, and even more. Let's start with defining data analysis. So the current area is called the information age, not simply because we humans have become so data rich, but also because society has reached a certain maturity in analyzing and extracting information from the data, with artificial intelligence and machine learning increasingly playing an important role. Companies such as Alphabet, Google, Amazon, Apple, Facebook, Netflix and Microsoft, which have built their businesses on data, are ranked among the most valuable companies in the world because they don't simply gather and keep stored the data that's provided by the digital processors. All these companies also know how to make data as valuable as oil by employing precise and elaborate data analysis. Google, for instance, records data from the web and from its own search engine, among other sources, and based on that data, it has built a plurality of machine learning models that are continuously updated to support its business. You may have heard already that data is a new oil, so in the news or magazines or all around the earth. The statement implies that data can make a company rich and that it takes skills and hard work to make this happen. So the most basic data transformations are provided by data analyzers, and you liken them to the basic chemical transformation that oil undergoes in a refinery before becoming valuable fuel or plastic products. Using just data analysis, you can lay down the foundation for more advanced data analysis processes that you can even apply to data. Data analysis, depending on the context, refers to a large body of possible data operations, sometimes specific to certain industries or tasks as well. Now you can categorize all the transformation into 4 large and general families. So once again, you see here the process of inspecting, cleansing, transforming, interpreting data to discover useful information, drawing conclusion, and support decision making. That would be the data analysis. Now the current era, what we mentioned is here, and here as well, we have a video that we could show. Hopefully it works. Let me check. Okay, so it seems to work, and I hope that you can hear also the sound from the video as well. Let's start.
데이터는 땡땡이다. 데이터가 중요한 시대입니다. 좋은 데이터를 많이 가지고 있는 조직이 유리합니다. 과거의 데이터는 거래의 기록이었습니다. 지금은 소셜, 모바일, 그리고 IoT까지 모든 것이 데이터로 기록되고 있습니다. 데이터는 땡땡이다라는 표현이 많이 쓰이고 있습니다. 땡땡에는 어떤 단어들이 사용될 수 있을까요? 데이터는 새로운 석유이다. 영국의 수학자이면서 테스코의 클로카드를 설계한 클라이브 험비는 2006년에 데이터는 새로운 석유이다 라고 말했습니다. 이후로 많은 사람들이 험비의 말을 인용해서 사용하고 있습니다. 험비는 왜 데이터를 석유에 비유했을까요? 다음과 같은 내용이 있습니다. 데이터는 석유처럼 가치가 있다. 그렇지만 원유와 마찬가지로 그대로는 사용할 수 없다. 원유는 정제 과정을 거쳐서 휘발유도 되고 플라스틱도 된다. 마찬가지로 데이터는 분석 과정을 거쳐서 가치를 발휘한다. 2006년이면 아직 빅데이터 개념은 논의되기 한참 전입니다. 시대를 앞선 통찰력이 놀랍습니다. 데이터는 새로운 흙이다. 영국의 데이터 저널리스트 데이비드 맥칸들리스는 2010년 테드에서 데이터 시각화에 대해 이야기하는 자리에서 데이터는 새로운 흙이라고 이야기했습니다. 다음과 같은 내용이 있습니다. 사람들은 정보 가부와 데이터 과잉으로 고통받고 있습니다. 해결책은 우리의 눈을 사용하는 것입니다. 데이터를 시각화하면 패턴을 눈으로 확인할 수 있습니다. 석유는 그 자체로 가치가 있습니다. 이를 가공하면 또 다른 가치를 갖게 됩니다. 데이터는 그 자체로 가치가 없습니다. 시각화 과정을 거치면 가치 있는 통찰을 얻게 됩니다. 이러한 성격은 흙과 같습니다. 흙은 그 자체로는 가치가 없습니다. 이런 점에서 흙과 데이터는 비슷한 점이 있습니다. 맥칸들리스의 테드 스피치는 다음 사이트에서 확인할 수 있습니다. 개인 데이터는 새로운 통화이다. 미국의 프리랜서 저널리스트인 데이비드 작스는 2011년 MIT 테크놀로지 리뷰에 개인 데이터는 새로운 통화인가라는 글을 게재했습니다. 다음과 같은 내용이 있습니다. 페이스북 사용료는 공짜입니다. 사용자는 디지털 포럼을 통해서 친구들과 그리고 친척들과 교류할 수 있습니다. 사진과 댓글을 공유할 수 있습니다. 그리고 이 모든 것을 이용하는 것은 무료입니다. 사용자에게 이보다 더 좋은 일은 없을 것입니다. 하지만 마크 주커버그는 페이스북 IPO를 통해 24억 달러를 벌게 됩니다. 페이스북 사용료는 공짜인데 주커버그는 어떻게 큰 돈을 벌 수 있을까요? 광고입니다. 페이스북은 사용자가 제공하는 데이터를 소유합니다. 그리고 그 데이터로 돈을 법니다. 그렇다면 페이스북은 사용자에게 돈을 지불해야 하는 것은 아닐까요? 이러한 생각은 데이터 권리가 데이터 주체인 개인에게 있다는 생각과 통합니다. 지금은 마이데이터 패러다임으로 자리 잡고 있습니다. 데이터는 21세기의 원유이고 애널리틱스는 연소기관이다. 가트너의 수석 부사장 피터 손더가드는 2011년 가트너 심포지엄에서 정보는 21세기의 원유이고 애널리틱스는 원유를 사용하는 엔진이다라고 말했습니다. 데이터가 가치를 발휘하기 위해서는 애널리틱스가 필요하다는 뜻입니다. 석유가 아무리 많아도 엔진이 없으면 석유는 에너지를 발휘하지 못합니다. 마찬가지로 데이터가 아무리 많아도 애널리틱스가 없으면 데이터는 통찰을 발휘하지 못합니다. 데이터 부채를 해결해야 한다. ASG 테크놀로지스의 이안 로우랜드는 2012년 데이터 버서티에 데이터 부채에 대한 글을 썼습니다. 다음과 같은 내용이 있습니다. 데이터 부채는 기술 부채라는 용어에서 생각을 빌려온 것입니다. 기술 부채는 워드 커닝햄이 1992년에 만든 용어입니다. 애플리케이션 영역에서 개발 조직들이 당장 개발 편의성을 위해서 미래의 비용이 발생할 수도 있는 상태를 내버려두는 현상을 말합니다. 데이터 영역에서는 패러독스가 있습니다. 데이터 수집이 아무리 쉬워지고 데이터 저장 장치 비용이 아무리 싸게 된다고 하더라도 데이터로부터 충분한 가치를 뽑아내는 일은 여전히 미흡하다는 것입니다. 그 이유는 데이터 부채를 해결하지 않고 내버려두기 때문입니다. 빅데이터라는 단어를 많이 사용하게 된 것은 2012년부터입니다. 그리고 지금도 많은 조직들은 데이터 부채를 안고 있습니다. 데이터는 새로운 통화이다. 타타손스의 회장 샨드라 세카라는 2015년 세계경제포럼에서 데이터는 새로운 통화인가라는 주제로 발표를 했습니다. 다음과 같은 내용이 있습니다. 지금의 디지털 세상에서는 소비자들의 기대가 상승하고 있습니다. 그들이 원하는 시간에 원하는 곳에서 원하는 서비스를 받을 수 있을 것으로 기대합니다. 이러한 일들을 수행하는 것이 불가능하지는 않습니다. 대규모로 생성된 데이터를 분석하면 기업들은 소비자의 니즈를 충족시킬 수 있습니다. 이런 점에서 데이터는 새로운 통화라고 믿습니다. 데이터를 활용하면 고객이 원하는 서비스를 제공할 수 있고 이는 수익으로 연결된다는 뜻입니다. 데이터 가치가 바로 실현되는 세상이 되었다는 뜻입니다. 데이터는 새로운 자본이다. 2015년 MIT 테크놀로지 리뷰는 데이터 자본의 대두, 더 라이즈 오브 데이터 캐피털이라는 아티클을 발간했습니다. 다음과 같은 내용이 있습니다. 과거에는 컴퓨터 장비를 중요한 자산으로 생각했습니다. 반면에 데이터는 자산으로 평가하지 않았습니다. 요즘은 하드웨어는 점차 서비스로 구매하고 있습니다. 하드웨어는 더 이상 자산이 아닙니다. 마지막 남은 자산은 바로 데이터입니다. 대부분의 기업가들에게 데이터는 가장 큰 자산입니다. 그럼에도 불구하고 기업의 CEO들은 이러한 사실을 잘 알지 못합니다. 지금은 기업 가치를 평가할 때 데이터가 가장 중요한 영향을 미칩니다. 데이터 확보를 목적으로 인수합병이 이루어지기도 합니다. 데이터는 가장 가치 있는 자산이다. 2017년 이코노미스트에는 세상에 가장 가치 있는 자산은 이제 더 이상 원유가 아니다. 데이터이다라는 글이 실렸습니다. 다음과 같은 내용을 담고 있습니다. 디지털 시대 원유는 데이터입니다. 데이터를 많이 가지고 있는 거인들이 지배하는 시대입니다. 알파벳, 아마존, 애플, 페이스북, 마이크로소프트 같은 타이탄들이 데이터를 독차지하고 있습니다. 그리고 이들 기업은 상장 기업으로서 가치가 가장 큰 기업들입니다. 아마존은 미국 온라인 거래의 50%를 차지하고 있습니다. 구글과 페이스북은 2016년 미국의 디지털 광고의 대부분을 차지하고 있습니다. 데이터를 지배하는 기업이 비즈니스도 지배한다는 현상을 정확하게 설명하고 있습니다. 데이터는 새로운 석유가 아니다. 2017년 bbc.com에는 데이터는 새로운 석유가 아니다라는 글이 실렸습니다. 데이터가 새로운 자원이 아니라는 것을 말하는 것은 아닙니다. 데이터는 석유가 아니라는 점을 말하는 것입니다. 다음과 같은 내용이 실렸습니다. 데이터와 석유는 다릅니다. 첫째, 석유 공급은 한정되어 있습니다. 그렇지만 데이터는 무한합니다. 데이터는 석유라기보다는 태양광에 더 비슷합니다. 그래서 데이터는 어디에 있는지 찾는 것보다 어떻게 공유할 것인가에 더 관심을 두게 됩니다. 둘째, 데이터는 재사용될 수 있습니다. 또한 서로 다른 사람이 서로 다른 목적으로 사용해도 됩니다. 셋째, 의외의 관심이 다릅니다. 개인 데이터의 유출 또는 남용은 더욱 심각한 문제입니다. 데이터가 석유와 완전히 다른 자원이고 따라서 활용 및 접근 방법이 달라야 된다는 점을 강조하고 있습니다. 데이터는 새로운 석유가 아니다. 새로운 원자력이다. 2018년 ideasted.com에서는 데이터는 새로운 석유가 아니라 원자력이라는 글이 실렸습니다. 다음과 같은 내용을 담고 있습니다. 데이터를 추출하고 정제하고 사용하는 것은 땅과 공기를 오염시킵니다. 데이터는 모든 것에 스며듭니다. 사람들의 사회적 관계의 지하수에 침투하여 독이 됩니다. 사람들은 컴퓨터처럼 생각하게 만들고 잘못된 관점에 빠지기도 합니다. 데이터가 잘못 사용될 때 발생할 수 있는 피해는 원유보다 훨씬 더 크다는 점을 강조하고 있습니다. 데이터는 새로운 석유가 아니다. 도그 레이니는 2001년 빅데이터의 특성을 3V로 설명하여 유명해졌습니다. 도그 레이니는 가트너 그룹을 거쳐서 지금은 웨스트몬로에서 이노베이션 펠로우로 일하고 있습니다. 도그 레이니는 2021년 4월에 열린 엔터프라이즈 데이터 월드 컨퍼런스에서 데이터 모네타이제이션 워크숍을 진행했습니다. 워크숍에서는 레이니는 데이터는 새로운 석유가 아니라고 했습니다. 자산인 것은 맞지만 데이터의 특성이 석유와 다른 점이 많다는 것입니다.
So I think that I should stop here now because the majority of the topic was covered. And then it is written here, so how much data is available for analysis in Korea was about 5% in 2019. This is also based on the reality that most of data copyrighted or belongs to some people, and it's not that easy to link or they break the link between the person or the owner of the data and the data itself. Well, this is it. You can continue with this video. I'm not going to do that. I close now the website and I'm going to continue with the lecture topic itself. So data analysis isn't a magic. We know that. You perform transformations, cleansing, inspecting, visualization, and modeling by using mass summation and multiplication based on matrix calculations, which is nothing more than the long sequence of summation and multiplication that many people learn in schools. Let's see a few points. So, 4 large categories we see here: transforming, so changing the data's structure itself. The term transforming refers to different processes. Three, the most common is putting data into ordered rows and columns in a matrix format. Well, for instance, you can't effectively process data of goods bought in a supermarket until you've placed each customer information in a separate row, like in an Excel sheet as well. Transforming can also involve numeric operations such as scaling and shifting, through which you can change the mean, so the average, and the dispersion, the way of numeric series is spread around its mean of the data. Now, these adjustments make the data compatible with machine learning and deep learning algorithms. The next step is cleansing, or category is cleansing, fixing imperfect data. Depending on the source of the data, you may find various problems. Sometimes there are missing information, or extremes, or outliers, and simply just because wrong values were recorded. So, for instance, the data in a supermarket may present errors when goods are labeled with incorrect prices. And for instance, a product may have fake reviews on the internet that change its ranking as well. Cleansing helps to remove adversarial examples, from data and make conclusions also reliable. Next is the inspecting category, which is about validating the data. So data analysis is mainly a human job, though software, of course, has a big role. Humans can easily recognize patterns and spot strange data elements. For this reason, well, data analysis produces many data-related statistics and provides useful and insightful visualizations. And the next is modeling, so grasping the relationship between the elements represented in data. So to perform this task, you need tools taken from statistics such as correlation, chi-quadrat, or chi-square test, linear regression, and many others that can reveal whether some values truly are different from others or just related. Okay, my favor is here buying diapers. The people who buy diapers, they also tend to buy more bottles of beer. This is interesting, but it's very true. I am also a father, so yes, it's indeed true. So no magic, as we mentioned already. The data analysis arsenal also provides basic statistical tools such as mean and variance that describe data distribution, or sophisticated tools such as correlation and linear regression analysis that reveal whether you can relate events or phenomena to one another based on the evidence. And well, what sometimes complicates data analysis is the vast volume of data that requires special computing tools. In this case, so Hadoop or Apache Spark can help us, which are two software tools used to perform massive data operations or on multiple computers. Now, despite such advanced tools, it's still a matter of perspiration to manually prepare your data. Let's see understanding why analysis is so important. I have a video link here above, as you realize as well. This time I would say, well, take your time if you want to know more. So it's about a 30 minutes long video. Obviously, I can't share during the presentation. So, data analysis is essential to AI. Well, in fact, no modern AI is possible without visualizing, cleansing, transforming, and modeling data before advanced algorithms such as machine learning, natural language processing, computer vision, or generative AI enter the process and turn it into information of even higher value than ever before. So in the beginning, when AI consisted of purely algorithmic solutions and expert systems, scientists and experts carefully prepared the data to feed them. Therefore, for instance, if someone wanted to develop an algorithm to process information, a data expert would place the correct data into lists, so order sequences of data elements, which I mentioned, for example, data, so workbooks in Excel, like that, or CSV files, or in another structured data format, a data structure, or XML files in that way, that could appropriately contain the information and allow its desired manipulation. At such a time, data experts gathered and organized the data so that its content and form were exactly as expected. And crafting new data for the purpose required a lot of time and energy. Consequently, algorithms had to work with less information than is available today. Now, attention has been shifted from data production to data preparation through data analysis. The idea is that various sources already produce data in such a large quantity that you can find what you need without having to create special data for the task. More data also makes the algorithm smarter than ever before. Imagine wanting an AI based on computer vision to control your pet door, to let cats and ducks in but keep other animals out. Modern AI algorithms learn from task-specific data, which means processing many images showing examples of data, for example, dogs and cats and other animals. Such a huge set of images would come from the internet, usually from social media platforms or image searches. Also previously, accomplishing a similar task meant that algorithms would use just a few specific data inputs selected because they did a good job of illustrating shapes, sizes, and distinctive characteristics of the animals. Now, however, scarcity of data once restricted the algorithms to only a few specific tasks. Remarkably, there are no examples of AI systems that could power a pet door using traditional algorithms or expert systems. Now, data analysis comes to rescue of modern algorithms by removing bad examples from transforming it accurately and according to the requirements, which provides further useful information. Now, for example, if the data is about images retrieved from the internet, data analysis enables the selection of the data based on the image sizes, the variety, the number of colors, words used in the image titles, in metadata, and so forth. This is part of the process of inspecting the data, and in this case, that's necessary before you can cleanse and transform it. So data analysis can help you spot a photo of animal, erroneously label the cat, and provide you the information to transform the image to the same color format and same size. Let's continue with reconsidering the value of data. With the explosion of data availability on digital devices, data assumes new nuances of value and useful beyond its initial scope of teaching and transmitting knowledge. The abundance of data were provided to data analysis and complex algorithms allows for new descriptive and predictive functions beyond mere reporting. So data describes the world better because it presents a wide variety of facts and in more detail by providing nuances for each fact. And data shows how facts are associated with events. Given enough data to dig out the underlying general rules, you can predict how the world will change or transform over time. Large amounts of scientific data can allow scientists to approach problems without hypotheses. Instead, analyzing the information found in data and using intelligent algorithms. Now, this contrasts, once again, this contrasts with the past when scientists relied on uncountable observations and a multitude of experiments to gather enough evidence to describe the physics of the universe using scientific method. However, this new data-driven approach to science would merely complement, not replace, the scientific method that has proven so effective in allowing scientists to find many underlying laws of the world. Now we can continue with defining machine learning itself. Well, the top of or high point of data analysis is machine language, and you can successfully apply machine learning only after data analysis provides correctly prepared input. However, only machine learning can associate a series of outputs and inputs as well as determine the working rules behind the output in an effective way. So data analysis concentrates on understanding and manipulating the data so that it can become more useful and provide insights into the world versus machine learning that strictly focuses on taking inputs from data and elaborating a working internal representation of the world that you can use for practical purposes. So machine learning enables people to perform activities such as forecasting the future, classifying things in a meaningful way, and determining the optimal rational decision in a given context. This central idea behind machine learning is that you can represent reliability by using a mathematical function that the algorithm doesn't know in advance but can guess after seeing some data. You can express reality and all its challenging complexity in terms of unknown mathematical functions that machine learning algorithms find and make actionable. Now, this concept is the core idea of all kinds of machine learning algorithms. Learning in machine learning is purely mathematical, and it ends by associating certain inputs with certain outputs. It has nothing to do with understanding what the algorithm has learned. So, the learning process is often described as training because the algorithm is trained to match the correct answer. So, the output to every question offered the input. Now, despite lacking deliberate understanding and being simply a mathematical process, machine learning can prove useful in many tasks. When learning occurs by using the right data, it provides the AI application the power to do the most rational thing given a certain context. Now, let's see here the goals again, focus and primary use case. You see here the main goal of data analysis is about understanding trends and insights. So data analysis is more about statistics, focusing on interpretation and visualization. Again, statistics. And then primary use case, so business intelligence and reporting tools. And in the case of machine learning, this is a little bit different. It builds predictive models and automate decisions. Rather than statistics, it relies on mathematics, pattern recognition, and automation. So once patterns are recognized, these patterns can be used and applied or reapplied for other processes. And then that is fraud detection and recommendation systems such as shopping through Coupang. So you are interested in, let's say, buying height zero beer, then you are also might be you might be also interested in cloud beer, which is zero alcohol and zero of sugar, whatever. So like that. Okay, not so fast, slow down, let's see. So here again, we talk about descriptive statistics, mean, median, and variance. Data cleansing and transformation we mentioned before, right? Also visualizations, so charts, graphs, dashboard, and hypothesis testing and correlation analysis. So these are the techniques of data analysis. Versus the machine learning techniques, where we have the three kinds of learning through machine learning. So the three kinds: supervised learning, unsupervised, and reinforcement learning. And then here, the supervised learning is about regression and classification, clustering, dimensionality reduction is about unsupervised learning, and then neural networks and deep learning we also have inside machine learning. So deep learning is just one single segment of machine learning. In the case of industry analysis, the data analysis example shows in finance, healthcare, and marketing a different picture from machine learning examples. So you see here, analyzing stock trends is about data analysis, and predicting stock prices is about machine learning. Healthcare is about identifying disease trends through data analysis, and machine learning helps diagnosing diseases here. And then marketing is about, in the case of data analysis, is about customer segmentation, and then we also have here the personalized recommendations through machine learning. Now, choose data analysis if you are interested in understanding trends, making data-driven business decisions and reporting insights, and choose machine learning if you want to build predictive models, automate decision-making, and develop AI-related applications. Many professionals use both skills in real-world applications, as data analysis is often the first step before applying machine learning models. I'm doing it also when it comes to investments in different instruments such as corporate bond or also state-run bonds and also stock exchange, so stocks of different companies. Good. Now, still defining learning. So the core concept of all kinds of machine learning that you can represent reality by using mathematical function that the algorithm doesn't know in advance but can guess after seeing some data, and you can express reality. And it's all challenging complexity in terms of unknown mathematical functions that machine learning algorithms find and make actionable. Once again, learning in machine learning. So yes, learning in machine learning, purely mathematical, and it ends by associating certain inputs with certain outputs we just mentioned before. And when learning occurs by using the right data, it provides the AI application the power to do the most rational thing and given a certain context as well. Okay, now this is about understanding how machine learning actually works. So many people are used to the idea that software applications start with writing a function that accepts data as input and that provides a result as well. For example, a programmer might create a function called add that accepts two values as input, let's say 3 and 5, and then provides a result which is in our case 8. The output of this process is the value. In the past, writing a program meant understanding the function used to manipulate data to create a given result with certain inputs. Machine learning turns this process around. So in this case, a given result with certain inputs. Machine learning, again, turns this around. So in this case, you know that you have inputs such as 1 and 2, or 3 and 5, and the desired result is going to be 8. However, you don't know what the function to apply to create the desired result. Training provides a learner algorithm with all such sorts of examples of the desired inputs and results expected from those inputs. So the learner then uses this input to create a function. In other words, training is the process whereby the learner algorithm tailors a function to the data. The output is typically a numeric value, such as a measure or a probability. To give an idea of what happens in the training process, imagine a child learning to distinguish trees from other objects. Before the child can do so in an independent fashion, the teacher presents the child with a certain number of tree images, complete with all the facts that make a tree distinguishable from other objects of the world. Such facts could be features such as a tree's materials, a wooden, its parts like trunk, branches, leaves, needles, roots, and the location so planted into the soil. The child produces an idea of what a tree looks like by contrasting the display of tree features with the image of other different objects, such as pieces of furniture that are made of wood but but do not share other characteristics with the tree. So a machine learning classifier works in a similar way. Under the hood, it defines a mathematical formulation that processes all the given inputs in a way that distinguishes a tree from other objects. First, this process assumes the existence of a suitable mathematical representation of a task, often referred to as a target function. Next, the algorithm searches to identify an approximate to this target. So we got the target function, and the ability to identify a variety of mathematical formulations is known as a representation capability of a machine learning, or also ML, or machine learning algorithm. A target function is assumed to exist for a machine learning algorithm to work, but it may not exist, or it may prove infeasible to find given the circumstances. Making a machine learning algorithm work involves dealing with uncertainty of the results and a certain degree of complexity. So here we go. In the end, the process of training a machine learning algorithm is more empirical than theoretical, so more practical in that way, requiring experimentation and a solid validation of the obtained results. Using a mathematical perspective, you can express the representation process in machine learning by using an equivalent term like mapping. Mapping happens when you figure out the construction of a function by observing its outputs and associating them with their respective inputs. So a successful mapping in machine learning is similar to a child internalizing the idea of an object. Oops. The child understands the abstract rules derived from the facts of the world in an effective way, so that when the child sees a tree, for example, they immediately recognize it as a tree. Such a representation, that is, the abstract rules derived from real-world facts, is possible because the learning algorithm has many internal parameters consisting of vectors and matrices of numeric values. Such parameters equate to the algorithm's memory for ideas that are suitable for its mapping activity that connects features to response classes. The dimensions and type of internal parameters delimit the type of target functions that an algorithm can learn. So during the learning process, an optimization engine in an algorithm changes parameters from their initial values during learning to represent an approximate target function. And during optimization, the algorithm searches through possible variants of its parameter combinations until it finds one that allows the most accurate mapping between features and classes. Now, this process evaluates many potential candidate target functions from among those the learning algorithm can generate. And it is about efficiency in this way. The set of all the potential functions that the learning algorithm that can discover is the hypothesis space. And the resulting classifier with its set parameters is called the hypothesis, a way in machine learning to say that the algorithm has set parameters to approximate the target function and is now ready to define the correct classification in any new situation. Now, for a machine learning algorithm to be performing effectively, its hypothesis space must contain a large range of parameter variants, allowing it to fit any unknown target function when solving a classification problem. Different algorithms can have different hypothesis spaces, obviously. What really matters is that the hypothesis space contains the target function or a suitable approximation, which is a different but similarly working function. Now you can imagine this phase as a time when a child experiments with many different creative ideas by assembling knowledge and experiences in an effort to create a visualization of a tree. So naturally, the parents are involved in this phase. In machine learning, someone has to provide the right learning algorithms, supply some unlearnable parameters called hyperparameters, choose a set of examples to learn from, and select the features that accompany the examples. Just as a child can always learn to distinguish between right and wrong, so machine learning and AI algorithm in general need guidance from human beings to learn efficiently and correctly. Let's continue with understanding the benefits of machine learning. So you find actually machine learning and AI used in a great number of applications today. The technology works so effectively that often its presence goes unnoticed anymore, so you don't see it well. In fact, you might be surprised to find that many devices in your home already incorporate both technologies, so AI and machine learning. Both technologies appear in your car and the workplace as well. Now, in reality, you can find AI used in many other ways, including some that you might not immediately associate with an AI. Access control is the first. In many cases, access control is a yes or no proposition. An employee smart card grants access to a resource, much like traditional keys have done for centuries. Though some locks do offer the capability to set times and dates that access is allowed, such core hours grained control doesn't answer every need. By using machine language and deep learning, it becomes possible to ascertain whether an employee should gain access to a certain resource based on role and the requirements. For example, based on attribute-based access control, so ABAC, powered by a deep learning algorithm, an employee can gain access to a training room when the training reflects an employee's role and needs. Then the next one is animal protection. The ocean might seem large enough to allow animals and ships to cohabitate without the problem. Unfortunately, many animals even then get hit by ships each year. A machine learning algorithm utilizing sensors and cameras as inputs enables ships to avoid collision with animals such as whales, by learning the sounds and characteristics of both the animal and the shape. The next one is about the predicting of waiting times. So queuing. Most people don't like waiting when they have no idea how long the wait will be. In healthcare settings or in the banks as well, accurately predicting waiting time is crucial for patients to make informed decisions. Machine learning allows an application to determine waiting times based on staffing levels, workload, complexity of the situation, and the problems the staff is trying to solve, availability of resources, and so forth. Now, let's see being useful, being mundane. So, specifying the limits. So even the movies suggest that AI is sure to make a huge splash, and you occasionally see extraordinary uses for AI in real life. Most uses for AI are mundane and very boring even. But now let's continue with specifying the limits of machine learning. Currently, it's unclear whether machine learning can provide the sort of AI that the movies present. In reality, even the most sophisticated algorithms can't think, feel, display any form of self-awareness or exercise free will. What machine learning can do is perform predictive analytics much faster than a human does. As a result, machine learning can help humans work more efficiently when handling vast amounts of information. The present state of AI involves just performing analysis and returning the results. Humans must still consider the implications of that analysis and make a required moral and ethical decisions. So not AI is nice to you, but AI is trained to be nice to you. Now, the main point of confusion between learning and intelligence is people's assumption that simply because a machine gets better at a job, it automatically displays intelligence and can handle any new task, which is not true. Nothing supports this kind of view of machine learning. Similar confusion occurs when people assume that the computer is purposely causing problems for them. The computer can't experience emotion, can't feel anything, acts only on an input provided and the instructions contained within an application to process that input. A true artificial intelligence will eventually emerge when computers can finally emulate the intricate combination of the following processes observed in the nature: genetics, learning, exploration, and creativity. So genetics is a slow adaptation of traits from one generation to the next generation. Then learning, so fast learning from organized and unorganized sources. Exploration, so spontaneous learning through intentional curiosity and interaction with others. And then creativity, so picking up new learning by improvisation and creative response to situations. Apart from the fact that machine learning consists of mathematical functions optimized for a certain purpose, other weaknesses expose the limitations of machine learning. You need to consider these three important limits as well. So, limits in representation. Representing some problems using mathematical functions isn't easy, especially with complex problems like mimicking a human brain. At the moment, machine learning can solve singular well-defined problems that answer simple questions such as what is this, how much is this, what comes next. Even the more advanced generative AI applications simply predict the next word or phrase in a sequence based on probability, lacking abstract or symbolic reasoning capabilities. So the next problem is the overfitting. Machine learning algorithms can seem to learn what you care about, but they actually often don't. Frequently, their internal functions mostly memorize the data without learning any general role. Overfitting occurs when your algorithm learns too much from your data up to the point of creating functions and then rules that don't exist. Lack of effective generalization because of limited data. The algorithm learns what you showed it. If you show too little data for the task, it won't learn to perform it. If you provide flawed, biased, or weird data, the algorithm will behave in an unexpected and undesired ways as well. So representation and learning algorithm can tackle various tasks, but not every algorithm is suited for every problem. Some algorithms are adaptable enough to learn to play chess, recognize faces on Facebook, and diagnose cancer in patients. Some other algorithms, known as foundational models, are also versatile, that they can be easily adapted to other tasks by means of further training. In contrast, other algorithms can only handle one task at a time, so they are highly specialized, and they need to forget what they have previously learned before being ready for different activities. A secret to machine learning is generalization. The goal is to generalize the output function so that it works on data beyond the training examples. However, the pursuit of generalization introduces new challenges such as overfitting and biased data. So where certain elements are overweighted or overrepresented. Now, for example, consider machine learning based web filter. The English language is estimated to have about 170,000 words, and usually average adult uses 20 to 35,000 words in their vocabulary. A limited training data set of about 5,000 email examples must create a generalized function that can then find spam in all the possible combinations of words that can appear in an email, which is an astronomical number that far exceeds the capacity of any computer calculate. In such conditions, the algorithm trained on such a limited choice of examples will seem to learn the rules of the language, but in reality, it won't do well. The algorithm may respond correctly to context similar to those used to train, but it will be clueless in completely new situations. Or it may even show biases in an unexpected way because of the kind of data used to train it. Now, for example, long before the OpenAI's ChatGPT was there, Microsoft trained its own AI, Taya, to chat with human beings on Twitter and learn from their answers. Unfortunately, the interactions went haywire because users expose state to high speech, raising concerns about the goodness of any AI powered by machine learning technology. The problem was that the ML, so machine learning algorithm, was fed bad, unfiltered data, which biased the result and forced Microsoft to retire this AI. Now let's move and consider how to learn from data. As for now, I believe that here I stop and continue with this topic later on. So what we have learned, let's see that quickly. Let's take a short summary here. So defining data, understanding why analysis is important, and reconsidering the value. We also differentiated between why data analysis is important and how machine learning differs from that as well. So here we go. What happens with the data? The 4 large parts: transforming, cleansing, and then inspecting and modeling from the data we have. So again, data analysis techniques and machine learning techniques. Data analysis statistics oriented, and machine learning more mathematics oriented as well. Accordingly, key differences are there in finance, healthcare, and marketing, but all the other industries also I could mention here. So we'll just take these 3 sectors right now: so finance, healthcare, and marketing. And data analysis examples are different from machine learning examples as well. And then we continued with defining machine learning, and we have talked about the target function. The process assumes the existence of suitable mathematical representation for a task, often referred to target function, and the representation capability we talked about, and the target function itself again. So and the making a machine learning algorithm work involves dealing with the uncertainty of the results and a certain degree of complexity. And we talked about mapping as well. And mapping happens when you figure out the construction of a function by observing its outputs and associating them with the respective inputs. Then we also talked about the optimization, and the set of all potential functions that the learning algorithm can discover is a hypothesis space, and the resulting classifier is called a hypothesis together with its set of parameters. Okay, then we continued with access control, animal protection, and predicting waiting times. In applications, machine learning and AI are there already. And we talked about the certain limits of machine learning. And here we go as well, the intricate combination of these processes, observing the natures of genetics, learning, exploration, and creativity. And we moved to the limitations. Here we go. Limits the representation, overfitting, and lack of effective generalization because of limited data. And the goal is to generalize, but we also have to think about the potential of overfitting or biased data. And actually, from now, the next part of the class is presented here. So thank you very much for your attention, and I hope that things can go well for you as well when continuing again with part 2. So part 1 is from chapter 5 is now over. Once again, thank you.